Good day, guys. This is your tutor engineer. Today we are continuing with our series on functions. Today I'll be covering a parabola graph. So let's start. Given a function g of x is equal to minus 3x squared plus 3. Question 1, calculate g of minus 1, g of 0, and g of 1. Okay, so g of minus 1 is equal to, where there is x, you just replace by minus 1, and then this is minus 3 plus 3, which is 0, and then g of 0, we do likewise, replace x by 0, and then you'll have 3, then g of 1, do the same thing. This will be minus 3 plus 3, which is 0. Okay, that's the first question. Now the second question is use the answer to 5.1 to write down the 3 elements of the domain of G and the 2 elements of the range of G. So the domain are the x values and the range is the y values. So we'll use the first question to answer question 2. So the x values is minus 1, 0, and 1. So we'll write those 3 elements as the domain. So it's minus 1, 0, and 1. And then the 2 elements for the range would be, it's 0, 3, and 0 again. So we'll just write 0 and 3. Those are the 2 elements. So let's go to question 3. Draw the graph of g of x for the domain x element of real numbers. Okay, to draw a graph, you must ensure that you have your x-intercept and your y-intercept. So let's start with the x-intercept. We'll easily set y equals 0, and then we solve for x, right, to get the x-intercept. So here divide by minus 3 both sides, then x squared is 1, then you can just put a square root sign on both sides, then you'll get x is plus or minus 1, right? So the x-intercept will be minus 1, 0, and 1 and 0. So that's the x-intercept. Then the y-intercept, you likewise set x equals 0, then you get g of 0. We've already worked out x equals 0 from the first question, so we found 3, right? So let's just write 3 as our y-intercept. So yes, this will be the same as the turning point as well. So the y-intercept and the turning point would be shared. So now let's plot the graph. So here on the y-axis, we'll have minus 1, 1. So on the x-axis and then the y-axis, you can just say 1, 2, 3. And then there's y-intercept, it's 3. X-intercept minus 1, x-intercept, x positive 1. So now let's just plot a graph. Just choose a black color for that. So the graph will turn at 3, which is also the y-intercept. So this is graph G. Okay, that's it for question 3, and then let's go to question 4. Use the graph to explain why g of x is a function. So to test if whether the graph is a function, you use a vertical line test, right? Vertical line test. Cut the graph once, right? So how did I write a vertical? Okay, let's just change this. I wanted to write vertical, must get the spelling right. Vertical line test cuts the graph once. You can see that the y-axis is the vertical line which cuts the graph only once, so that makes it a function. What kind of a function is g of x? Okay, to answer that question, we first need to go to the first question, the very first question. We saw that when we replaced x by -1, we found the value of y to be 0, and also when you replace x by 1, we also found a 0. So for two different values of x, you get the same value of y. So that makes it a kind of function called many-to-one function. So for many values of x, you get one value of y. So the answer here is many-to-one function. Okay, now let's go to question 5. The graph of g of f of x is equal to ax squared, where x is less than or equal to 0, is sketched alongside. The point A, -2 and 5 lies on f. So this is -2 and 5. Point A lies on f. The first question is determine the value of A. So let's determine the value of A. Okay, in order to determine the value of A, we have the function f of x, and then we have the A coordinate. So let's write the function f of x. Those are the two tools we're going to use to calculate the value of A. So instead of y, we'll replace by y coordinate of 5. Then instead of x, we'll replace by -2, which is the x coordinate. So we'll solve for A from here. Here you'll have 4a divided by 4 both sides. Then A is 5/4. So that means we can rewrite our function as 5/4 x squared. So that would be question 1, 5.1, and then 5.2, determine the equation of the inverse. So you need to determine the equation of the inverse from here. Let's write here 5.2. You first have to write the function f in terms of y in order to get the inverse, and then from here you swap the values of y and x around. Here you'll have x instead of y, and then instead of x you'll put a y, and then you start solving for y from here. So you'll multiply by 4/5 both sides of the equation. It will give us y squared is equal to 4x/5. Then to solve for y, you put a square root sign on both sides. We'll find y is equal to 2, which is going to be plus or negative x/5. Right, so this is going to be the function. Since we are dealing with the inverse is going to be reflected on the line y is equal to x, right? So the inverse is going to be on the fourth quadrant. So the equation of the inverse would be now the negative portion of the graph. So we'll just say minus 2 x over 5, since the y from here is negative going this way. So that's gonna be the equation of the inverse. Let's just call it the inverse of f. Yes, just like that. And then let's go to question 5.3. Write down the domain of f and the range of the inverse. So 5.3, let's just write it closer to the graph so that you see. Okay, let's write 5.3 here. So the domain of the function f, it's the values of x starting from minus infinity, or we can just say x is less than or equal to 0, meaning from 0 going this way up until infinity, where x is the element of real numbers. Then when it comes to the range for the inverse, we're just going to swap the domain around for the range. So we'll say y is less than or equal to 0, where y is the element of real numbers. So that's really the answer to question 5.3. 5.4 says draw the graph of the inverse on the same set of axes. So okay, we've already established the line. That's the first thing you must do. You must establish the line y is equal to x, and then you plot the inverse reflecting about that particular line. Okay, so let's choose a purple color for the inverse. So this line will be the mirror image of our inverse graph. So our inverse will look something like this. So this is the graph of f, and this will be our inverse. And then that's it for this particular question, 5.4. And then 5.5 says if the graph of f is reflected in the y-axis and then reflected in the line y is equal to x, write the equation of the new function. Okay, let's just demonstrate that. Okay, they are basically saying the graph of f, you take the graph of f, you reflect it about the y-axis, so it will look something like that. This will be the reflection, where y-axis is the mirror image. So this is the second half of the original graph of f, and then you take the very same reflection about the y-axis, you reflect it about the line y is equal to x, right? So it's going to be something like that. So the equation of this function is going to be the other half of the inverse, right, which is positive. Remember, the equation of the inverse is negative. We've already established under the second question that the inverse is minus 2 x over 5, right? So the top portion, the new equation would be plus 2 root x divided by 5, square root x divided by 5. So that would be the equation of the new function. So that would be the answer to question 5.5. Okay, now let's deal with question 2. Question 2 says, given the function of f of x, this is the function, draw the graph of f of x and its inverse on the same set of axes, clearly show all intercepts with the axis, asymptotes, and lines of symmetry. So this graph, you know that this is a parabola. This is a parabola graph. So in order to plot it, let's start by working out the x-axis. We'll set y equals to 0, and then we'll solve for x. So now we have x squared minus 1, x minus 3 squared minus 1 is equals to 0. Okay, and then when you solve for x here, we'll have, you can just do this, take 1 the other side, then put a square root sign, then you'll have plus or minus 1. Then you can say x is equal to 3 when you take it to the side, plus or minus 1. So that means x is either 4 or x is either 2. So x-intercept is 4 and 0 and 2 and 0. So you can just quickly mark it. This is your x-axis, y-axis. So if you have 1, 2, 3, 4, so you have a 2 here, you have a 4 here. That means this will be your x-intercept. Now let's deal with the y-intercept. You likewise set x equals to 0, and then you will work f of 0 will be equal to 0 minus 3 squared minus 1. Then here you'll get 9 minus 1, and then you'll get an 8. So this is the y-intercept. You can likewise mark it. 8 is about there. Then we have the y-intercept. And then when it comes to the turning point, remember our original equation for f is x minus 3 squared minus 1. So you'll get the coordinate of the turning point there. So this equation, you can rewrite it as, or rearrange it rather, is going to be minus 3. So you say here plus minus 1. So I wanted you to see those signs there, and then you'll be able to deduce and take out the turning point. So the turning point will be 3 and minus 1. Just make sure in order for you to take out the turning point, you have a minus here, then you have a plus, and then the turning point is going to be 3 and minus 1. So 3 is here, then minus 1 is here, right? So the turning point should be here. So now let's plot the graph. It's going to be a very smooth graph. Going towards infinity on both sides. So just label it graph f. So the turning point here is 3 minus 1. So now remember, the question says you must also plot the inverse. So now it's easy to plot the inverse once you have the original graph plotted on the same set of axes. So you're just gonna plot this line, y is equal to x, to plot the inverse, and then you just swap everything around when you're plotting the inverse. Let's just choose color purple for the inverse. What do I mean by swapping everything around? It means since you have x-intercepted 2 and 4, those x-intercept will become your y-intercept. So they'll become your new y-intercept for your inverse graph. And then your turning point was 3 and minus 1. So that means the turning point for your inverse will be minus 1 and 3. So you're swapping everything around. So 3 is here, minus 1 is here. That will be the new turning point of your inverse graph. And then your y was 8 for your original function. That means your x-intercept will be 8. That will be a new x-intercept. So let's just plot this graph. It's gonna look something like this. And then it's gonna cut the y-axis at 8. Sorry, the x-axis at 8. So we'll just label it as the inverse. And our new turning point is minus 1 and 3. Okay, that's it for this question. Now the final question is, write the equation of the inverse of x in a form of y is equal to. So, okay, the original function of, okay, let's write here question B. Remember, f of x is x minus 3 squared minus 1. To write to get the equation of the inverse, you first have to write f of x in terms of y, and then from here on you swap x and y around, and then you start solving for y. So here you can just add 1 on both sides, then you'll have y minus 3 squared. This side, let's just rub this off. And then the other side will have x plus 1. Then you can start solving for y from here. Put a square root on both sides, then you'll have y minus 3 is equal to plus or minus x plus 1. Then this can be written as taking 3 to the right hand side. So this is your inverse. Sorry, minus 1 f of x. So this is your inverse. Okay, we'll stop here for today, our lesson. So if you enjoyed today's lesson, there's more where that came from, please subscribe and stay tuned on the next lesson. Cheers.